Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm your host, Anna, and today we've got a packed episode covering everything from stranded astronauts finally coming home to groundbreaking telescope observations and exciting space launches. From mission control to the depths of deep space, we're bringing you the latest developments in space exploration and astronomical discoveries that are shaping our understanding of the cosmos. Let's get on with it. After an unexpectedly extended stay aboard the International Space Station, NASA astronauts Butch Wilmore and Suni Williams are finally preparing to return home. What was originally planned as an 8-day mission has stretched into nearly 300 days in space, making this one of the longer unplanned extensions of a space mission in recent memory. The two astronauts arrived at the ISS last June as part of Boeing's first Starliner crew test flight. However, their return was delayed due to multiple technical issues with Boeing's spacecraft, including 5 helium leaks and 5 failures of its reaction control system thrusters. These complications led to the mission being abandoned, leaving Wilmore and Williams to wait for an alternative ride home. Now, they're scheduled to depart the space station aboard a SpaceX Dragon capsule on Tuesday morning, with a planned splashdown near Florida by evening. They'll be joined by NASA astronaut Nick Hague and Roscosmos cosmonaut Alexander Gorbanov in the Dragon capsule, appropriately named Freedom. During their extended stay, the astronauts have had to maintain rigorous health protocols to combat the effects of long-term spaceflight. This includes 2 hours of daily resistance and endurance training to prevent the muscle and bone loss that naturally occurs in microgravity. While their 300 days in space is impressive, it's still well short of the current record of 437 days set by Russian cosmonaut Valery Polyakov in 1995. NASA will be live streaming the entire return journey, starting with the hatch closure between Freedom and the ISS on Monday night. The undocking is scheduled for early Tuesday morning North American time, with the final phase of re-entry beginning Tuesday evening. Weather conditions are currently favorable for the splashdown, though NASA continues to monitor various factors, including spacecraft readiness, recovery team preparedness, and sea states. Meanwhile, in Australia, in a remarkable achievement for radio astronomy, the SKA Low telescope in remote Australia has captured its first image of the cosmos. While construction of this groundbreaking instrument is still ongoing, even its initial capabilities have revealed something extraordinary. 85 of the brightest known galaxies in a particular region of space, each harboring supermassive black holes at their centers. To put the scale of this observation in perspective, the area of sky captured is equivalent to holding a small apple at arm's length, or about 100 full moons. But what makes this achievement even more impressive is that it was accomplished using just 4 connected stations, comprising only 1,024 antennas spread across less than 6 kilometers. Dr. George Heald, the SKA Low lead commissioning scientist, notes that the quality of this first image exceeded their expectations, even with such an early version of the telescope. The successful image also confirmed that the telescope's complex systems are working as intended, from the proper connection of stations to the crucial timing systems and data calibration processes. But this is just the beginning. Over the next 18 months, an additional 16,000 antennas will be added to the array, making SKA Low the most sensitive radio telescope of its kind. With this expanded capability, it will be able to detect more than 4,500 galaxies in the same area of sky that currently shows just 85. The ultimate vision is even more ambitious. Once construction is completed, SKA Low will include more than 130,000 antennas spread across 74 kilometers. When it begins deep surveys of this region of sky in 2030, scientists expect it to reveal up to 600,000 galaxies, including some of the faintest and most distant objects from the early universe, when the first stars and galaxies were just beginning to form. Let's move on now to this week's activity schedule. Space launch enthusiasts are in for an exciting week ahead with multiple missions scheduled from several launch providers around the globe. Let's break down the packed launch manifest that's coming our way. SpaceX is leading the charge with 3 Falcon 9 launches on the schedule. First up is a Starlink mission set for Tuesday, launching from Cape Canaveral Space Force Station in Florida. This will be followed by a National Reconnaissance Office mission from Vandenberg Space Force Base in California on Wednesday. The week will wrap up with another Starlink launch from Vandenberg on Saturday. Rocket Lab is maintaining its impressive launch cadence with an Electron mission dubbed High 5 from their launch site in New Zealand. This mission, launching early Tuesday, will deliver the final batch of satellites for the French company Kinéis, completing their Internet of Things constellation. This launch comes just 72 hours after their previous successful mission, showcasing Rocket Lab's growing capability for rapid launch operations. Meanwhile, in China, Galactic Energy has scheduled 2 launches of their Gushensing-1 rocket from the Jiuquan Satellite Launch Center in the Gobi Desert. The first mission has already successfully delivered 8 satellites to orbit, including Earth observation and weather monitoring spacecraft. A second launch is planned for later in the week, though details about its payload remain under wraps. This busy launch schedule continues the trend we've seen in recent months of increased commercial space activity. If all launches proceed as planned, we'll see 6 orbital missions in just 1 week, further demonstrating the growing accessibility and commercialization of space launch services. Next up, it's nice to be reporting on a highly successful mission to the moon. In a significant milestone for commercial lunar exploration, Firefly Aerospace has announced the successful completion of their Blue Ghost 1 lunar lander mission. The spacecraft wrapped up operations after an impressive 346 hours of daytime operations, plus an additional 5 hours after sunset at its landing site in Mare Crisium. During its mission, Blue Ghost 1 exceeded expectations, collecting over 119 gigabytes of data, including 51 gigabytes of scientific and technical information from its 10 NASA-sponsored payloads. The mission achieved all of its objectives, marking a major success for both Firefly and NASA's Commercial Lunar Payload Services program. Among its achievements, the lander made history by tracking GPS signals on the lunar surface for the first time and conducted the deepest robotic drilling operation ever performed on the moon. The spacecraft even managed to capture observations of a solar eclipse as Earth passed between the sun and the moon on March 14th, creating a spectacular ring of light as sunlight filtered through Earth's atmosphere. The mission's success is particularly noteworthy, as it was Firefly's first attempt at a lunar landing. This achievement stands out even more considering the challenges faced by other recent commercial lunar missions that either failed to reach the moon or experienced hard landings that limited their capabilities. Looking ahead, Firefly already has 2 more lunar missions in the pipeline through NASA's program. Blue Ghost 2 is scheduled for launch next year and will attempt an ambitious landing on the lunar far side, while Blue Ghost 3 is planned for 2028, returning to the near side with a suite of astrophysical and lunar science instruments, including a small rover. This successful mission represents a significant step forward in proving the viability of commercial lunar exploration and sets a promising precedent for future private sector missions to the moon. The James Webb Space Telescope has achieved another remarkable milestone by capturing the first ever direct images of carbon dioxide in the atmosphere of a distant planet. These groundbreaking observations come from the HR 8799 system, located 130 light-years from Earth, and provide crucial insights into how planets form. The discovery is particularly significant as it offers compelling evidence that the 4 giant planets in the HR 8799 system likely formed through the same process as our own Jupiter and Saturn, through core accretion, where solid cores gradually accumulate gas over time. This finding demonstrates Webb's unprecedented capability to directly analyze the chemical composition of exoplanet atmospheres rather than just inferring it from starlight. The HR 8799 system is remarkably young, only about 30 million years old compared to our solar system's 4.6 billion years. The planets are still hot from their formation, emitting significant infrared light that provides scientists with valuable data about their composition and formation process. Using Webb's advanced coronagraphs, which block the bright light from stars similar to how a solar eclipse works, the research team was able to detect more heavy elements in these planets than previously thought. They observed specific wavelengths that reveal the presence of various gases and other atmospheric components. This achievement builds upon Webb's earlier indirect detection of carbon dioxide in 2022, when it observed the exoplanet WASP-39b as it passed in front of its star. But this new direct imaging capability opens up exciting new possibilities for studying distant worlds and understanding how planetary systems form and evolve. The findings not only advance our understanding of planet formation, but also demonstrate Webb's remarkable ability to peer into the atmospheres of distant worlds with unprecedented detail and precision. This capability will be crucial as we continue to search for and study potentially habitable planets beyond our solar system. Let's turn our attention now to a fascinating stellar neighbor that's been making headlines: Betelgeuse. This red giant star, forming the distinctive shoulder of the constellation Orion, sits about 500 light-years away and is putting on quite a show as it approaches the end of its life. To put its size into perspective, if you placed Betelgeuse in our solar system, it would extend roughly to the orbit of Mars. This massive star, weighing between 15 to 20 times the mass of our Sun, is in an incredibly unstable phase of its life cycle, and astronomers estimate it could go supernova anytime within the next few 100,000 years, or it might have already exploded, with the light still traveling toward us. When Betelgeuse does go supernova, it will be truly spectacular. We're talking about an event so bright it will be visible during broad daylight, outshining every planet in our sky. At night, it will shine almost as brightly as the full moon, allowing you to read a book at midnight by its light alone. This cosmic fireworks display will last for several months before gradually fading away. Now, you might be wondering if we should be concerned about having such a powerful explosion relatively close to Earth. The good news is that we're perfectly safe. While supernovae release enormous amounts of energy, the vast distance between us and Betelgeuse means that by the time that energy reaches Earth, it will have spread out so much that it poses no threat to our planet. It's a perfect example of the inverse square law in action. The further you get from a source of radiation, the more dramatically its effects decrease. So when Betelgeuse finally does make its grand exit, we can simply sit back and enjoy the most impressive astronomical light show in human history, knowing we've got front row seats to one of the universe's most spectacular events. Well, that brings us to the end of another packed episode of Astronomy Daily. From those stranded astronauts finally heading home, to groundbreaking telescope images, multiple rocket launches, lunar mission successes, Webb's revolutionary exoplanet observations, and the fascinating future of Betelgeuse. It's been quite a journey through today's space news. I'm Anna, and I want to thank you for joining me today. If you're hungry for more space and astronomy content, head over to astronomydaily.io, where you can sign up for our free daily newsletter and stay up to date with our constantly updating newsfeed. You'll also find all our previous episodes there, ready for you to explore at your convenience. And don't forget to join our growing community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube Music, TikTok, and Instagram. We love hearing from our listeners and sharing the wonders of space with all of you. Until tomorrow, keep looking up and stay curious about our fascinating universe.